Okay, on to homework number 9. Use the compound interest formulas A equals blah and P equals blah to solve the problem given. That's clunky. Round answers to the nearest penny. Find the accumulated value of an investment of $10,000 for 4 years at an interest rate of 4% if the money is compounded semi-annually, compounded quarterly, monthly, and continuously. So this is the equation that we will utilize for continuously compounded interest. This will be the equation we use otherwise. So we only use A equals P times E. E is a number raised to the APR times Y. That equation is only used when we're working with continuously compounded interest. The giveaway is this number E. So the other 3 instances will utilize this formula, and the giveaway there is the fact that N is showing up. So N in this equation represents the number of times the interest is applied in a given year. So semi-annually, N is 2, quarterly, N is 4, monthly, N is 12. Continuously, N is essentially infinite. You can't work with an infinite just sitting in your equation. So we appeal to this, this version, essentially. So let's go ahead and work on compounded semi-annually. So semi-annually, 2 L's. Semi-annually. So N equals 2 in this case. Semi-annually would be twice a year, so N is 2. So semi-annually, all that's really telling you is N is equal to 2 for the equation. Let's go ahead and write this equation out. So in order to utilize this equation, we need to identify P, we need to identify APR. We've already identified what N is, and then Y. So P is the principal. N is the number of times interest is applied per year. Y is the number of years. And APR is your interest rate. Or annualized percentage rate, I believe, is what APR stands for. So we're told find the accumulated value of an investment of $10,000. So this principal is going to be 10,000. Number of times interest is applied per year, well, semi-annually, N is 2. The number of years we're doing this, we're told the 10,000 sits for 4 years. And lastly, the interest rate we are given is 4%. So let's go ahead and fill in these numbers into this general equation. So we have A equals 10,000 multiplied by 1 plus APR, which is 4%. Percents are not numbers, percents are comparisons. So this will be 0.04 divided by N, which is 2, raised to the 2 times Y, which is 4. All right, I'll appeal to the calculator, and here's exactly why I recommend the TI-36X Pro. It has the nice pretty print, or I think what they call is the multi-view. So 10,000 multiplied by 1 plus 0.04 divided by 2, all raised to the 2 times 4. Now keep in mind, if you do not have a calculator with this nice little pretty print feature, you will need to type in this equation into your standard 2-line calculator appropriately, which will look like this: 10,000 times left parenthesis 1 plus 0.04 divided by 2. Your calculator should recognize the order of operations and do this division before it executes the addition. And then you'll need to raise that, so you'll utilize the caret key. And you want to raise that to the quantity of 2 times 4. This chunk does need to be parenthesized, or else it'll raise it to the second power, take the result, and multiply by 4. However, you want to simply take this base and raise it to the 2 times 4. So this would be the notation if you do not have the very handy pretty print on your calculator. In either case, you should end up with 11,716.593.593. How do they want the answer? Answers to the nearest penny. So nearest penny is going to be this 9er. 3 is not big enough to round up the 9. So we'll go ahead and say it's 11,716.59. 11,716.59. Compounded quarterly. So recognize all of this is the same. The only thing that's changing is the number of times that interest is applied. So quarterly and so quarterly would be once every 4 months, or I'm sorry, quarterly would be applied 4 times a year, so that'd be every 3 months. So n is 4. So simply come back to your equation in your calculator and change the 2 into a 4. Again, and that's because the only thing that's going to change is the number of times the interest is applied. Remember, the number of years, it's still setting for 4 years. We still have a 4% interest rate. We still have a principal of 10,000. So the only thing that changes between semi-annually and quarterly is the n value. This gives us 11,725.76 is enough to round up my 8, so it'll be 79. 11,725.79. Okay, on to monthly. In fact, I'll just use the back of this one. So monthly. And as you might suspect, n is 12. So we'll come back to our calculator and we'll change the 4s into 12s. The appropriate 4s into 12s. This gives me 11,731.986, which we will round to 11,731.96 is enough to round up my 8, so 99. 11,731.99. All right. Compounded continuously. So continuously. Sorry. All right. So we have A equals P times E raised to the APR by Y. So again, our principal is still 10,000, and we're going to multiply it by the number e raised to the APR, which is still 0.04, times number of years, which is 4. So on your calculator, that e should be somewhere close to a natural log or an exponentiation button. So you are looking for the number e in your calculator. Every calculator should have one. 10,000 times e raised to the 0.04 times 4. And we get 11,735.108, which is enough to round up. So we get 11,735.11. Okay, so something to take note of these numbers. Notice these numbers gradually increase. So when we went from semi-annually to quarterly, there was an increase. From quarterly to monthly, there was an increase. And from monthly to continuously, there was also an increase. And that increase does make sense because the interest being compounded semi-annually in the first box, that would mean your interest is applied twice a year. However, towards the bottom, compounded monthly, your interest would be applied 12 times a year. So recognize in applying the interest more times in a given year, you end up getting more. So the more the interest is applied, the more this sum will grow. So notice when the interest is applied continuously, we do get some growth. And in fact, this should be the largest value. So that's a good way to check during a test, is that your compounded continuously should be greater than these previous three. Also, notice this compounded continuously is pretty close to compounded monthly, only a difference of right around $4. So notice not only do these sums grow as you approach the compounded continuously, you tend to grow less. So notice there's a bigger jump between semi-annually and quarterly, and then a smaller jump between quarterly and monthly, and then an even smaller jump between monthly and continuously. And continuously is the largest value of these four. So good things to check during a testing situation. Let's try our moment of truth. Nice. All right. So let's jump back to problem number 1 real quick. The rest of these are identical to what we just did. So use the appropriate compound interest formula to compute the balance in the account after the stated period of time. $8,000 is invested for 15 years with an APR of 5% and monthly compounding. So monthly compounding, well, that says N is 12. Our principal P is 8,000. That's what's being invested. We're doing it for 15 years, so Y is 15. And we have an APR of 5%, which we will need to enter as a decimal into our equation. So A is 8,000 times 1 plus 0.05 over N, which is 12. And then we're going to raise that to the APR times Y. 8,000 times 1 plus APR over Y, all raised to the interest rate times the number of years. Wait, no, I messed that one up. This should be N, so I want 12 here, not the interest rate. The reason why I saw that is, if you notice, this exponent, so 12 is the number of times the interest is applied in a year, 15 is the number of years you're doing this, so this exponent is the total number of times the interest is applied. So that's what raised a red flag in my head with this 0.05 in the exponent. Again, this exponent turns out to be 12 times 5, which is the total number of times the interest is applied. So changing this 0.05 into the 12, of which it should be, we get 16,909.631. Round to the nearest cent as needed. 1 is not enough to round up to 3. So 16,909.63. Oh, you be quiet, computer. 16,909.63. Moment of truth. All right. Good luck on this homework. I'll see you on the next one.